Before laying a single brick on Mars, you have to solve the biggest problem: getting there. The journey is a long one, and to build a city, you don't just send a few astronauts. You need to move millions of tons of cargo. So, how do you do it? This is where SpaceX's Starship changes everything. Starship is designed to be the most powerful, fully, and rapidly reusable rocket ever built. That reusability is the magic key. A typical rocket launch can cost a fortune, but by reusing Starship, SpaceX aims to slash that cost, making the economics of Mars actually work. It's a total game changer, designed to carry up to 100 people at a time or 150 tons of cargo into orbit. The plan itself is mind-bending. A Starship launches to Earth's orbit, and then a fleet of tanker starships meet it to refuel it for the long haul to Mars. This kind of complex orbital refueling has never been done on this scale, but it's a critical step that SpaceX hopes to demonstrate. Earth and Mars only align for an efficient trip once every 26 months. During these windows, the vision is to launch a whole fleet of starships. While the timelines are famously ambitious, the first uncrewed Pathfinder missions are targeted for as early as 2026, acting as robotic scouts to test the landing and see what we're up against. Okay, so you've landed on Mars. Now what? How do the first pioneers survive in one of the most hostile environments we know? Mars has a thin atmosphere, no magnetic field to shield from deadly solar radiation, and temperatures that can drop to bone-chilling lows. The solution, at first, is brilliantly simple. The first Martian habitats will be the starships that brought them there. Already pressurized and equipped with life support, they provide instant shelter. The first crewed mission, which Elon Musk has optimistically targeted for as soon as 2029, would likely be a small crew of about a dozen people. Their mission: survive and set up. One of their very first jobs will be deploying power systems. With help from companion robots like Tesla's Optimus, they'll unload and unfurl vast solar arrays, establishing an initial power grid. This will power the early base and kickstart the most important job of all: finding local resources. But solar power has a major weakness on Mars: planet-wide dust storms that can block the sun for weeks. That's why the colony will need a reliable backup, likely in the form of small, modular nuclear reactors to make sure the lights always stay on. These first steps are all about gaining a foothold, a tiny bubble of Earth on an alien world. Just surviving isn't enough. To build a real city, you need to build it out of local materials. You can't just ship water, air, and fuel for 1 million people from Earth. This is where a concept called in-situ resource utilization, or ISRU, becomes the foundation of the whole plan. It's a fancy term for a simple idea: living off the land. It turns out Mars is richer in resources than you might think. NASA has confirmed vast deposits of water ice just below the surface. Robotic miners could dig up this icy soil, or regolith, and heat it to release water vapor, which can then be collected. With water, everything changes. Using a process called electrolysis, you can split water H2O into breathable oxygen and hydrogen. The oxygen fills habitats and also acts as a rocket oxidizer. The Martian atmosphere, which is 95% carbon dioxide (CO), provides the other key ingredient. To make rocket fuel, SpaceX will use the Sabatier reaction, a clever bit of 19th century chemistry that's essential for 21st century exploration. By combining hydrogen from the water ice with carbon dioxide from the atmosphere, they can create methane chain, the very fuel that powers Starship's engines. This means starships that land on Mars can be refueled for a return trip, creating the first truly reusable to-planet transportation system. With fuel, water, and air, the next challenge is building a permanent home. Since shipping materials is out of the question, the Martians will build with what they have: Martian dirt. The loose soil and rock, called regolith, will become the primary construction material. The vision involves fleets of autonomous 3D printing robots that scoop up the regolith, mix it with binders, and print everything from landing pads to habitats, layer by layer. This isn't just theory. NASA is already testing similar technology on Earth with its CHAPIA program, where crews live for a year in a 3D printed simulated Mars habitat. But you can't just build on the surface. Mars is constantly bombarded by cosmic radiation at levels far higher than on Earth. To protect the first inhabitants, structures will either be built underground or covered with thick layers of compacted soil, which is a fantastic natural radiation shield. The city will likely start as a series of interconnected, buried pods and eventually grow into huge underground structures and massive domes, creating a shielded, human-friendly environment. Once there's shelter, people are going to get hungry. A city of 1 million will need a massive and reliable food source. The solution will probably look like something from a sci-fi movie: huge underground vertical farms. Crops like potatoes, wheat, and soybeans could be grown using hydroponics, a method that uses far less water than traditional farming. But what about protein? The most efficient source might just be insect farming. Crickets, for example, are packed with protein and can be raised sustainably in a closed system, providing a vital nutrient for a growing population. All of this will be powered by an expanding grid of solar and nuclear energy. Life support systems will recycle almost everything. On the International Space Station, about 93% of water is recycled. The goal for Mars is to push that to 98%, turning waste back into clean water and fertilizer. This closed-loop system is the only way a city so far from home can truly thrive. With power, food, and shelter, the colony can finally start to grow. So how do you get from a dozen explorers to a bustling city of 1 million by 2100? The growth is driven by that 26-month launch window, with each new fleet of Starships bringing more people and advanced equipment. The aspirational growth curve is exponential. The vision sees a population growing from a handful of pioneers to hundreds, then thousands, and eventually reaching 1 million by the turn of the next century. This growth would spark an economic boom. Industries could spring up around mining, scientific research, and propellant production. Manufacturing, centered on 3D printing, would produce everything from new habitat modules to pressurized rovers for exploration. And as the population grows, so does its society. The initial city will likely be run by SpaceX, but the long-term plan is for a transition to a self-governing body, perhaps with an elected council and a Martian constitution. The city itself would be an engineering marvel, a network of underground tunnels connecting vast, shielded habitats with large domes on the surface for parks and social spaces. The dream of building a city on Mars is one of the greatest undertakings humanity has ever imagined. It will test the limits of our engineering, our science, and our endurance. The timelines are ambitious, and there are countless challenges to overcome. But for the first time in history, the question is shifting from if to when. If you're as excited about the future of space exploration as we are, make sure to subscribe and hit that notification bell. What part of building a Martian city blows your mind the most? Let us know in the comments below. This isn't just about a backup plan for humanity, it's about adventure. It's about the drive to explore and build, proving that human ingenuity knows no planetary bounds. The blueprint is there, the engineering has begun. The journey to our second home has started.